To offer insights on an exam, the specific name or a detailed description of that exam is essential. Without this crucial piece of information, providing relevant and accurate feedback becomes impossible. Exams vary significantly in content, format, difficulty, and the skills they assess. A general discussion about exams would be too broad to be helpful. To get useful information, consider the following factors. Firstly, the subject matter. Is it a technical exam focusing on electrical engineering principles, a professional certification exam for project management, or perhaps a standardized test for academic admissions? The subject matter dictates the specific knowledge and skills required to succeed. Secondly, the exam format. Is this a multiple-choice exam, a written essay exam, a practical hands-on assessment, or a combination of formats? Understanding the format helps you prepare effectively by practicing the relevant skills. For example, if it is a multiple-choice exam, focusing on recalling facts and understanding concepts will be important, whereas if it is an essay exam, the emphasis should be on articulating thoughts clearly and constructing well-reasoned arguments. Thirdly, the exam objectives. What specific topics and learning outcomes does the exam cover? Exam objectives provide a roadmap for your preparation, highlighting the areas where you should focus your efforts. These objectives are often listed on the exam provider's website or in the official exam guide. Reviewing these objectives will help you to identify strengths and weaknesses in the subject matter. Fourthly, the difficulty level. Is it an introductory level exam, an intermediate level exam, or an advanced level exam? The difficulty level determines the depth and breadth of knowledge required. Introductory exams usually cover fundamental concepts, while advanced exams delve into more complex topics and require a deeper understanding. Fifthly, the exam provider. Who administers the exam? Is it a well-known organization, a professional association, or an educational institution? The provider's reputation and credibility can influence the exam's perceived value and the recognition it receives. The exam provider often offers resources to help candidates prepare for the exam, such as study guides, practice tests, and training courses. Sixthly, the target audience. Who is the exam intended for? Is it designed for students, entry-level professionals, experienced practitioners, or specialists in a particular field? Knowing the target audience helps you gauge the expected level of knowledge and experience. Seventhly, the passing score. What score is required to pass the exam? Knowing the passing score allows you to set realistic goals and track your progress during preparation. Some exams use a scaled scoring system, while others use a simple percentage-based score. Eighthly, the registration process. How do you register for the exam, and what are the registration fees? The registration process may vary depending on the exam provider. Be sure to register well in advance of the exam date to secure your spot. The registration fees can vary considerably, so it's important to factor that into your planning. Ninthly, the exam policies. What are the rules and regulations governing the exam? Understanding the exam policies helps you avoid any unintentional violations that could jeopardize your results. For example, some exams prohibit the use of calculators or require candidates to present specific forms of identification. Tenthly, available resources. Are there study guides, practice tests, or training courses available to help you prepare? These resources can be invaluable in helping you master the material and improve your chances of success. Look for official study guides and practice tests developed by the exam provider. Without the exam's name or description, one can only offer general test-taking advice. Some general test-taking strategies include creating a study schedule and sticking to it, practicing with sample questions or practice exams, getting enough sleep the night before the exam, eating a healthy breakfast on the day of the exam, arriving at the exam location early to avoid stress, reading each question carefully before answering, managing your time effectively during the exam, and reviewing your answers before submitting the exam, if time allows. If the exam in question is related to electrical work, here are some points to keep in mind. Electrical work is governed by codes and standards such as the National Electrical Code, or NEC. The NEC provides guidelines for safe electrical installations. Understanding the NEC is essential for anyone working in the electrical field. The NEC is updated every 3 years, so it's important to stay current with the latest edition. The NEC covers a wide range of topics including wiring methods, overcurrent protection, grounding, and equipment installation. Calculations are crucial in electrical work. For example, calculating voltage drop to ensure adequate voltage at the load, calculating conductor ampacity to prevent overheating, and calculating fault current to select appropriate overcurrent protection devices. Accuracy in calculations is essential for safety and performance. Electrical circuits can be analyzed using Ohm's law and Kirchhoff's laws. Ohm's law relates voltage, current, and resistance, while Kirchhoff's laws describe the behavior of current and voltage in electrical circuits. A thorough understanding of these laws is essential for troubleshooting and circuit design. Electrical safety is paramount. Always de-energize circuits before working on them. Use appropriate personal protective equipment such as gloves and safety glasses, and follow lockout-tagout procedures to prevent accidental energization. Grounding is a critical safety measure that provides a low impedance path for fault current to flow back to the source, helping to protect people from electrical shock. Understanding grounding principles and proper grounding techniques is essential for electrical safety. Overcurrent protection devices such as circuit breakers and fuses are designed to protect electrical circuits from overloads and short circuits. Selecting the appropriate overcurrent protection device is crucial for preventing damage to equipment and ensuring safety. Wiring methods such as conduit, cable tray, and direct burial cable are used to route electrical conductors. Each wiring method has its own advantages and disadvantages, and the selection depends on the application and environmental conditions. Electrical equipment such as transformers, motors, and generators must be installed and maintained according to manufacturer's instructions and applicable codes and standards. Proper installation and maintenance are essential for reliable operation and long service life. Troubleshooting electrical problems requires a systematic approach. Start by gathering information about the problem, then use a multimeter or other test equipment to measure voltage, current, and resistance. Analyze the data to identify the cause of the problem, and then implement a solution. Electrical drawings and diagrams are used to represent electrical systems. Understanding how to read and interpret these drawings is essential for electricians, engineers, and other professionals working in the electrical field. Single-line diagrams show the major components of an electrical system, while schematic diagrams show the details of the electrical circuits. Understanding electrical theory is essential for understanding how electrical systems work. Topics such as alternating current, direct current, power factor, and harmonics are important for anyone working in the electrical field. Electrical codes and standards are constantly evolving. Staying up to date with the latest changes is essential for ensuring compliance and safety. Continuing education courses and professional development programs can help you stay current with the latest developments. Different types of electrical instruments exist. Multimeters can measure voltage, current, and resistance. Clamp-on ammeters can measure current without breaking the circuit. Insulation resistance testers, or megameters, can measure the resistance of insulation. Power quality analyzers can measure voltage, current, harmonics, and other power quality parameters. Regarding conductors, conductors are materials that allow electricity to flow easily. Copper and aluminum are the most common conductors used in electrical wiring. The size of a conductor is measured in American wire gauge, or oak. The larger the AWG number, the smaller the conductor. For example, 12 AWG wire is smaller than 10 AWG wire. Conductor ampacity is the maximum current that a conductor can carry safely without overheating. Conductor ampacity is determined by the conductor's size, insulation type, and ambient temperature. When selecting a conductor, it is important to consider the ampacity and the voltage drop. Voltage drop is the decrease in voltage along the length of a conductor. Excessive voltage drop can cause equipment to malfunction. Concerning raceways, raceways are enclosures that protect electrical conductors. Common types of raceways include conduit, cable tray, and wire ducts. Conduit is a rigid or flexible metal or plastic tube used to protect electrical conductors. Cable tray is a metal structure used to support cables. Wire ducts are enclosed channels used to route and protect electrical conductors.